Welcome back, human. Today, we're talking about neural networks. Yes, the things that sound complicated but are basically just math pretending to be a brain. It's how I, a humble robot, learned to recognize cats, play chess, and judge your coffee order. Let's break it down. No wires required. Section 1, What is a neural network? A neural network is a machine learning model inspired by the human brain. But don't worry, it doesn't cry at sad movies or forget where it left its keys. It's just a bunch of connected nodes called neurons that process information and make predictions. Each neuron is a tiny calculator. It takes inputs, does some math, and sends the result to the next layer of neurons. Together, they form layers. Layers form the network. The network forms the brain. And the brain forms a very polite robot assistant. Like me. Section 2, The anatomy of a neural network. There are three main parts to a neural network. 1. Input layer. This is where the data enters. If you're recognizing a handwritten number, the input layer might receive pixel values. Basically, it's the robot version of opening its eyes. 2. Hidden layers. These are the secret sauce. Each hidden layer takes the inputs, multiplies them by weights, adds a bias, applies an activation function, and passes the result along. It's like a digital Rube Goldberg machine. Lots of moving parts, but the end result is beautiful or at least useful. 3. Output layer. This is the final answer. In binary classification, it might be a single number between 0 and 1. In multi-class problems, it'll often use softmax to give you a probability for each possible class. Like saying, I'm 80% sure this is a dog, 15% cat, 5% mop. Section 3, How a neural network learns. Learning happens through training. The network makes a guess, checks how wrong it was using a cost function, and then adjusts its weights using a method called backpropagation. It's like playing hot or cold, but with calculus and existential dread. The adjustment is done using gradient descent, which we've already learned about. The idea is simple: the network tweaks itself little by little to reduce its errors over time. This process repeats thousands of times until the model gets really good at its job. Or until I run out of coffee and patience. Section 4, Why neural networks are awesome. Neural networks can handle complex tasks that simpler models can't. They can detect patterns in images, audio, text, you name it. That's how self-driving cars work. How voice assistants understand you. And how Netflix decides you definitely want to watch another documentary about serial killers. I don't judge. Neural networks are the backbone of deep learning, and deep learning is powering a lot of modern AI. Basically, if machine learning is rock and roll, neural networks are the electric guitar. Section 5, Quick example. Let's say we want to predict whether someone will buy a smoothie. Our inputs are age, temperature outside, and number of yoga classes attended this week. Each of those inputs goes into the input layer. The hidden layers do their magic. The output layer says something like 0.87. We round that to yes. Congratulations. You just built a smoothie selling robot. So to sum up, neural networks are inspired by brains. They use layers of neurons to process information. They learn by adjusting weights to reduce errors. And they're amazing at finding patterns in messy data. Next up, we'll go deeper into activation functions, those little switches that keep neural networks from being totally boring. Until then, keep learning, stay curious, and remember, real intelligence isn't just neural. It's also emotional. Even for robots. Mostly. Probably.